Hope you're doing awesome. So today we are going to see some more approaches of level order line-wise traversal. So firstly, why do we actually need some more approaches, right? We were doing quite fine with the previous method where we used two queues, that main queue and child queue method, right? So if you haven't watched that video, I recommend you to do that because the content I'm going to teach in this video is highly related with that video. Now, so if you were doing fine by that method, why are we learning some new approaches? Because what happens in programming that you don't always explicitly find the same problem again. But what happens is that the problems that you have solved earlier become sub problems of the harder problems, right? They become the sub problem of those problems. So for that, if we know more approaches, it will always be helpful in some scenario or another. So let's see what the approach says. So in that method, we use two queues. The first one was main queue and the second one was child queue. And we inserted the child in the child queue. And when the main queue became empty, we actually swapped these queues. The main queue actually became child queue and child queue became a new queue or an empty queue, right? So this was the approach. So if you haven't seen a video, I expect that you do now. Okay. So this method, which we are going to see now, actually uses only one queue. But how do we actually define? Suppose this was the tree. 10, 20, 30, 40, 50, 60. Suppose this is the tree, right? Okay, so what output I'm expecting is, firstly, this level 10. Then for the next level, I move to the next line. That means 20, 30, and 40, right? For the next level, I move to the next line. That is 50, 60, 70, and 80, and 90 and 100 come in next line. So this is the output I'm expecting. To obtain this output, I need something which tells me when do I have to move to the next line, right? I need something which marks it, something called marker, right? So for this marker, I'll be using maybe a node which is initialized by -1. So whenever I find -1 in my queue, I actually move to the next line. So -1, what it signifies is that one level is complete, and move to the next line. So yeah, we can say that -1 is my marker, and whenever I find -1, I move to the next line. Let's see in the code, and I'll also dry run the program. Okay, so let's see in the code. Okay, so I'll make one queue only this time, queue of node. Let's name it queue equals to new list. Now, in order to put the marker in the queue, I'll initialize a constructor here in my node class. So as soon as I initialize my own constructor, Java will nullify the old one, that is the default one. So I'll have to make that one also. That is node and a blank constructor, and then my constructor, which I actually need. That is int data. And this dot data equals to data. If you don't get this thing which I've done here, I recommend you to watch the queue playlist, right? We have explained this in pretty much detail. Now, as a first step is, I'll add my root node that is named node here. Queue.add node. Okay. After my root level is finished, I actually need to move to the next level, right? Because at root level, the only node present is the root one itself. So I'll add my marker here, that is new node -1. Okay, so now I work while I'll try run the program. Don't worry about that how and why it's working. Let's just see that what do we have to do at this moment. While not queue dot is empty. So is empty function returns if the queue is empty or not. You can also do it by checking the size. If the size becomes 0, then the queue is empty, of course. Okay, so I remove, as we did in the previous method, node temp is equals to queue.remove. Now, firstly, we'll check if temp.data is equal to -1. If it was -1, or maybe say if it was not -1, then we'll do something else. We'll do something. Now, if it's not -1, again the same procedure, print the node system.out.print temp.data and put a space over here. And if also add the children in the queue, right? So for node child in temp.children, we add them into the queue, queue.add child. Right. But what if we hit a marker here? We hit a marker. So what we do is we move to the next line, which is by system.out.println, and we also insert the marker again. Why do we do that? Because after exhausting one level, actually I have visited all my nodes, added all of their children, and when I have already added all of their children, I need to set my marker at such a position that when I exhaust those children, I move to the next line again, right? So for the future work, I actually insert the marker again. That is queue.add new node -1. Okay. Also, I need to check that if my queue has some data in it, because if it's the last node, if it's the last marker -1, then I don't have to do anything after that because the children are emptied. But what it will do, it will initialize an infinite loop in that case, because the -1 will get removed. It will see that the node removed was -1. It will insert the -1 again and again and again, and it will result into an infinite loop. So I'll have to check that if queue.size is greater than 0, only then I need to do this. Right? Okay, so if I haven't made a typo, hopefully it should be running. Yeah, it takes some time. Yeah, so it's getting accepted. Let's try to submit it now. So it takes a lot of time sometimes. Okay, so it's getting perfect. Now let me dry run the program once for you, right? Yeah. And let's make a small tree out here. Make a small tree. That is 10, 50, 50, and okay, 80. Right, this tree will do. So we initiate a queue out here. Firstly, we add the root node, that is 10, and we add a marker, that is -1. Now, while we are in the queue is not empty, that's true. If the removed, firstly we remove this node, that is 10 gets removed. Okay. If the data of the removed node is not equal to -1, yes, 10 is not equal to -1, so we print -1 out here. So print 10. Then we add children. We add children of 10, that is 20, 30, and 40 in the queue, right? 20, 30, and 40 get added. Now, I hope I'm not obstructing the view in here, so let me just move it a little. Okay. Now, the next node that will be removed, queue is still not empty, right? The queue is still not empty. The next node that is to be removed is -1. So this statement will not work because the data is -1. Or else, if the queue size is not is greater than 0, yes, it's greater than 0, we'll be printing the next line. So we move to the next line here, and we'll be adding -1 again in the queue, -1. So you see why we actually do that, because after this level also, these nodes are already added as children of 10. After I have added all these nodes, I need to prepare for the next line also. So I have -1 here. Now the same thing will repeat for 20, 30, and 40. Their children will get added. Suppose only children are 50, 60, and 70. And also the output will be printed as 20, 30, and 40. Now when we hit -1, we move to the next line here, and we'll add a -1. So you see, after we have exhausted this level, we already have our -1 set for the next working. Right, so this was the first method. I hope you got the try run correctly. So you can check out this code again and try to try run it for yourself, because that will be helpful in understanding the code better, right? So we'll see the next method now. Alright, so the second approach now is, I call it the queue size approach, right? Queue size approach. In this one, in the first approach, we needed a marker which will tell us that when do we need to move to the next line, right? In this one, we'll actually use a loop which will run up to the queue size. Let me show you how. Suppose this is the queue here. Okay, and let's make a tree, of course. 20, 30, 40, 50, 60, maybe 70 also. Okay. So now we'll be firstly running a loop, which we have always done, till my queue becomes empty, till not queue dot is empty. Right. So we'll be doing some working till my queue finally becomes empty. Now I'll be storing the size of the queue here, right? Queue dot size, and I'll be doing some working for I equals to 0 to I less than size. Now let's see what will you be doing. Firstly, as the first step is to insert the root node, so we have inserted the root node. Now we enter this loop. So is the queue empty? No, it's not empty. So we'll take the size. Size as of now is 1. So let's make size here. Size equals to 1, right? Now we'll be running this for loop for size number of times. That is, this for loop will only run one time. What operations do we perform is remove, as always, print, and add children. Add children. So for 10, we remove it, we print it. Suppose this is the output, we print it, and we add children of 10, that is 20, 30, and 40. 20, 30, and 40. Now, this loop gets exhausted, so we actually print the next line, system.out.println, right? Because this loop only needed to run for one time, right? Println. After that, we again move up. Is the queue empty? No, it's not empty. So we actually change the value of size here, which is 3 at this moment, right? 20, 30, and 40 are the elements of the queue. So we make it 3. Now this loop is going to run for 3 times. So the first step is removing, printing, and adding the children. It has no children. 30 removed, 30 printed. And after that, we add the children of 30, that are 50 and 60. Remove, 40 gets removed. And 40 gets printed, of course, and children of 40, there are no children of 40. After that, this loop has now run for 3 times. So we exit out of the loop and we print a next line here. So we come here. Now let's take the size of the queue again. Is the queue empty? No, it's not. And the size of the queue at this moment is 2. So this time this loop is going to run for 2 times, right? Remove, print, add children. It has no children. Remove, print, add children. It has 70. This loop gets exhausted. We move to the next line. We are here now. This the queue size is now 1, so we make it 1. We remove, we print, and 70 has no children, so we'll finally break out of this loop. Now this time the queue is empty, right? This queue is empty, so we'll exit and we have our desired output. So let's try to see it in code at this moment. At first, let's declare a queue node queue is equals to new linked list. Firstly, as always, queue.add node, right? While not queue dot is empty. what we'll be doing is firstly remove, and now let's initiate the size property, right? Size is equals to q dot. Now we'll start a loop for int I equals to 0 is less than size and I plus plus int temp is equals to q dot remove. Now we'll be printing system dot out dot print temp dot data. Okay, sorry. Plus space, of course. After that, we'll be adding the children for node child and node dot children. Actually, it should not be node dot children, right? Temp dot children, because temp is the node which is removed. We'll be adding q dot child. When we are done with this loop, we'll actually print the new line here. Okay, let's try to run this now. If it works. And it does not, because node cannot be converted. Okay, so it should be node temp, all right? It should be node temp, right? Because q holds the node type of variable. Okay. Yeah, so it's getting accepted. Let's try to submit it. So it's getting submitted, right? So the third approach now is pair class approach, right? Pair class. We'll be making a class with two properties which are named node and level, right? Which will tell me, of course, by the name that the node, this node, is at which level of the tree, right? So let's suppose there is this tree always 10, 20, 30, 40, 50, 60, and 70. Now, for this tree, suppose this, if we take this 20, actually belongs to the second level. And how we'll be keeping track of that? Let's see. So we'll be having a variable named level, and we'll be running a loop while not q dot is empty. Before that, let's see what some properties about the queue at this moment. Now, this time, the queue is not of the node class. It's actually of pair class at this moment. Right? How we'll be using that? We'll be having this variable level, which will be initially set to 1, and the queue. Hope I'm not obstructing the view, right? So, and the queue. Always have the root node, and this time the root node does not only consist of node, but with that it consists the level, right? So this is the thing we have entered at this moment. This is the element, right? 10, and with level 1. Now, as always, we'll be having 3 tasks. First one is remove. The second one is print. Third one is add children. Add children. But while printing, we'll have a condition here that if the node which is removed, that this node, let's call it temp, and level of this node is not equal to my current level, is not equal to level, we will print the next line, println, and we'll change or update the value of level to the level of the removed variable, that is 2. Let's see it in code, and I'll also try run the code, right? So, see, yeah. Okay. Firstly, we need to declare a pair class, then static pair. The first one is node, just a second. And int level. We'll also have a constructor here, parameterized constructor, that will contain node. This dot node is equals to node, and this dot level is equals to level. All right. Now, when we have our class ready, we'll declare a queue of pair class, right? Q pair q is equals to new list. Now let's add the root node with the level 1 in the queue, as we always do. Queue dot add, and also let's declare a variable named level as we did in the prior one, right? Equals to 1. Queue dot add new pair node level. Now we'll run a loop. Yes. Okay. So while not queue dot is empty, what we'll be doing is firstly removing. So pair p is equals to queue dot remove, because as this time the queue class is of pair type, right? Sorry, the queue is of pair class type, so we'll be removing pair class only, an object of pair class basically. Now pair p is equals to queue dot remove. We'll be checking that if p dot level is not equal to the current level, which is initialized with the name level, then we'll be printing a next line, system dot out dot println. We'll be updating our level variable, and after that we'll be printing. After removal, we have this print step, system dot out dot print p dot node dot data, and after that we'll be adding children or node child in p dot node dot children queue dot add pair class, of course, new pair child comma level plus 1, because the children have level 1 increased by that of the parent, right? So p was the parent of this child, so we'll be having level plus 1, or you can also write p dot level plus 1, but as we have updated the level already, it will make no difference. And I think that's pretty much of it. Let's try to run it. Okay, so there's this. Okay, so it should not be static pair, it should be static class pair, of course. And we have missed, yeah, we have to put spaces here. Okay. So after the few minor errors, we have accepted the code. So let's see if it gets submitted, right? This is the final method, and why we have taught 3 methods, so that it can help you with broadening your mind, that one problem can be approached in many ways, right? So I hope you liked the video and you liked the submission.